Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video. By the end of it, you should be able to calculate probability of A or B, where A and B are mutually exclusive events. Now, we better start off by going through what mutually exclusive actually means. So we say that two events are mutually exclusive if they can't both happen at the same time. So mutual means they act on each other in the same way, and to exclude something means we're stopping it from happening. So two events are mutually exclusive if they stop each other from happening. Let's look at some examples. So for this first example, I roll a die and get an even number. I roll a die and get a prime number. This event and this event are not mutually exclusive because they can both happen at the same time. So they will both happen at the same time if I roll a 2. If I roll a 2, I've rolled an even number and I've also rolled a prime number at the same time. That's why these two are not mutually exclusive. But these two events are mutually exclusive. Get an A in science and get a B in science. You can't have both. If you get an A, that means you didn't get a B. If you got a B, it means you didn't get an A. Because they can't both happen at the same time, they are said to be mutually exclusive. So when events are mutually exclusive, it's very easy to calculate the probability one or both happens. So, using the events, I get an A in science and B in science, we're going to use this notation. So you know that this P means probability, and hopefully you remember this symbol here means OR. So this says probability of getting an A or a B in science. Now, just so you're aware, when we use this symbol in maths, we really mean A or B or both. Of course, in this case, both can't happen. So, to find the probability of getting an A or a B, all I need to do is add up the respective probabilities. So this is the formula for finding the probability of one event or another if the two events are mutually exclusive. I just add their probabilities. So if I know, for example, the probability of getting an A is 0.4, probability of getting a B is 0.5, probability of getting an A or a B is just those two added together, 0.4 plus 0.5, which gives me 0.9. Now, you're probably used to using this formula many times, even if you haven't seen it written like this. So let's say I just roll a normal 6-sided die. What's the probability of, say, getting a 2 or a 3? Well, you probably know that's really simple. It's just 2 over 6, because there are two ways I can get it, 2 or 3, and there are 6 outcomes in total. So, these two events are mutually exclusive. Rolling a 2 and rolling a 3 are mutually exclusive. If you roll a die, you can't roll a 2 and also roll a 3 at the same time. So, to find out the probability of a 2 or 3 another way, we could just find probability of rolling a 2, probability of rolling a 3, and adding them together. And of course, 1 over 6 plus 1 over 6 gives 2 over 6 or a third. Exactly the way you've been doing it. All right, let's look at a question that's slightly more challenging now. So let's try this question here. So let's say I toss a coin 6 times. So this notation here means probability I get no heads is 1 over 64. Probability I get all 6 heads is 1 over 64. Similarly, the probability I get 2 heads is 15 over 64. The probability I get 4 heads is 15 over 64. So we're going to calculate the probability I toss at least 2 heads. So this is saying at least 2 means I get 2 or 3 or 4 or 5 or 6 heads. Okay, obviously I can't get more than 6 heads. I'm only tossing the coin 6 times. Now, each of these events is mutually exclusive. If I toss 6 coins or toss a coin 6 times, I can't get 2 heads and simultaneously get 3 heads. I can't get 3 heads and also get 6 heads. That wouldn't make any sense. So all of these are mutually exclusive. So to find the probability that one of these happens, all I need to do is add up their respective probabilities. So it'll be the probability I get 2 heads plus the probability I get 3 heads, and so on. So I can just simply add up the numbers that are written up top. So probability of 2 plus the probability of 3. All these numbers are just coming up at the top. You don't have to figure out, how I figured out the probability of getting 3 heads is 20 over 64. We'll do that in later lessons. So I just keep adding these numbers. So adding up all of these, I get 57 over 64. If I toss a coin 6 times, probability I get at least 2 heads is 57 over 64. And that was calculated using the OR rule for mutually exclusive events. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.